Today we'll talk a little bit more about modeling with quadratic functions, given less information than yesterday, needing to write the equations, given some data, and we have two different ways to do this. So I'm going to show you both methods with the same problem, so you can see how to solve the same problem in two different ways. So today we're going to talk about NASA and how they can create a weightless environment by flying a plane in parabolic paths. And there's a clip of that in YouTube that I give you there if you're interested in seeing people flying in a plane. The table below shows heights, h in feet, of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. We're going to write and evaluate a function to approximate the height at which this occurs. So first we need to write the function, and then we'll plug in to approximate the height at which passengers start to feel weightless. So the biggest deal is getting the function. There are two methods. The first method we're going to deal with is using a system of three equations and three variables. In other words, our 3x3 systems that we've been solving for about a week now. So that's really the hardest part of this, is figuring out how to set that up. And you need to understand a lot of stuff. Because we're talking about a parabolic path, we're talking about a quadratic. So we have a function that's in the form y equals ax squared plus bx plus c. Now, we have a bunch of x's and y's here in our table, and we need to find our coefficients a, b, and c. That is why we need a system of three equations and three variables. We need to find the values of a, b, and c to plug them back in to our formula. So you can choose any three pairs of numbers here. I like the ones that seem prettiest and smallest. So I'm going to take all the times that end in 0, so 10, 20, and 30. And they're the three smallest times that end in 0. So the pairs are 10, 26,900, 20, 30,600, and 30, 32,100. We need to find our a, b, and c for those 3 points. So keeping in mind that our general form of an equation that's quadratic for a parabolic path is y equals ax squared plus bx plus c. We're going to plug in those xy pairs, those three xy pairs, to get our system to solve to find a, b, and c. So here we go. For the point 10, 26,900, my y value is 26,900, and that equals a times my x value, 10 squared, plus b times that x value of 10, plus c. I'll clean that up and put it in an order I'm kind of more used to. 10 squared is 100a plus 10b plus c equals 26,900. Again, I'm just looking ahead and knowing that when I solve a system, I'm used to my variables being on the left and my constant being on the right. It's not a big deal if you don't switch that up. For my second xy pair, my y is 30,600. That will be equal to a times its x, 20 squared, plus b times x, 20, plus c. Cleaning that up, I get 400a plus 20b plus c equals 30,600. And for my last xy pair that I chose, you could choose any three pairs of numbers. I have 32,100 equals a times 30 squared plus b times 30 plus c, or cleaned up, 900a plus 30b plus c equals 32,100. So now I have a system of three equations and three variables. You need to choose a variable to eliminate, and it looks to me like c is the obvious choice because I'll just need to negate one equation each time and add them together, and then plug back in to find your a and b. So I'm going to leave you to do that and try it to make the video shorter and just to give you more practice one more time of solving a 3x3 system. So pause the video now, practice that, and I'll be back with a solution. So check to see if you got the same thing I did. You should have gotten A is negative 11, B is 700, and C is 21,000. If you didn't get those, take some time to look for mistakes, but move on if not. Continue with the video and check later. So we need a function in the form y equals ax squared plus bx plus c. So now we can substitute our a, b, and c into that function. So our function is y is equals negative 11x squared plus 700x plus 21,000. There's the function that models the path of the airplane, getting me into weightlessness. Now the question asks for, at 20.8 seconds, how high is the plane? Because that's where weightlessness first occurs. So now what you need to do is substitute 20.8 seconds into your function and evaluate it. This is where you definitely want to use the store function in your calculator and be ashamed to go through all this work and make a mistake. So do that now. And you'll get 30,801 feet. So you want to write a little sentence in context. Passengers experience weightlessness at approximately 30,800 feet. Okay, well, that was a lot of fun and a very nice review of solving 3x3 systems. And when we're told we have to use a system, do it. But if you have a choice, I always choose technology. So let's start a new document on our nSpire. We'll want a Lists and Spreadsheets page and enter the data you were given for the NASA problem as time and height. Again, you need to name your variables in your top row and then enter all of your data. Feel free to pause, enter your data, fast forward, make sure you've entered it right, instead of watching me type. Okay, once you've entered your data, we add a data and statistics page. They always go with the Lists and Spreadsheets page. Your independent or x variable is time. Your dependent or y variable is height. And here it's really neat. You can clearly see the parabolic path of that airplane. Now what we want to do is find the model that best fits it. And since it is a parabola, we go to Analyze, a regression, but we choose Quadratic. Quadratics are parabolas. Show Quadratic. And there is our function. Again, y equals negative 11x squared plus 700x plus 21,000. Much faster and easier without the system, but sometimes you have to do the system. And then to finish up, again, add a calculator page, store that variable in t, because we're talking about time. 20.8 seconds is when they first experience weightlessness. Enter your function, negative 11t squared plus 700t plus 21,000. And there is the height at which that first happens. You might want to push your up arrow and copy that value down and see how they rounded, because you see the decimal there, it means they rounded. And you can see it's 0.96. It's fine for us right now to round to 0.1.